Number 18. Calculate at 25 degrees Celsius the pH of nitrous acid. نحن مرق معنا nitrous acid قبل, and you know that it is a weak acid. Okay, pay attention. Nitrous acid is not the same as nitric acid. Nitric acid, usually you do not have its pKa. That means it's a strong acid. Nitrous acid is a weak acid with a pKa of 3.2. Calculate the pH of this solution if it's 0.1 molar. Okay, good. I need a new page. No. Okay, it's okay. I need a new page for number 18. Number 18, you have part A. If C, عندكم أكيد nitric acid HNO2, you already هلا كل هدول details you don't have to write it. Okay, remember that. NO2 minus plus H3O plus. You have to find the pH. To find the pH, you follow the validity. أول validity tells you that the pH for a weak acid, when you have to assume that alpha is less than 10%, is basically half pKa minus half log C if this entire value is less or equal than pKa minus 1. You have to verify this لا تقولوا لي إنه the answer is correct. So it is basically nope. So it's basically half into pKa is 3.2 minus half log 10 to the negative 1. Is it less or equal than 3.2 minus 1? Okay, so log 0.1 is basically minus, so صار في عندك minus half, that's plus half, and 3.2 divided by 2, you get 2.1. Is it less or equal than 2.2? Yes, it is. This is valid. It means the pH is equal to 2.1. That's it. That's the answer. That's it. Okay? Part A, طالما أول validity is correct, you move to part B. Okay, part B, same question, بس هالمرة the concentration is 10 to the negative 3. Okay, 10 to the negative 3, you have to start from the first validity. You have to start from the first validity. The pH is equal to half 3.2 minus half log 10 to the negative 3. Is this less or equal than 2.2? So you calculated 3.2 divided by half minus log of 10 to the negative 3 اللي هي approximately 3.1. Is it less or equal than 2.2? No. This is not valid. Okay? Not valid. Go directly to the third validity that tells you A minus and HA coexist. ليش ما رحت على second validity؟ لأنه أصلاً 10 to the negative 3 is not enough according to Osgood law so that it behaves as a strong acid. No, there is no way that it can behave as a strong acid if you just change the concentration from 0.1 to 0.001. So go strictly to the third one. نحن قلنا إنه second is rarely seen. You can go strictly to the coexist validity اللي بتقولكم إنه find the value of H3O plus from your quadratic اللي هي basically H3O plus squared plus Ka اللي هي 10 to the negative 3.2 H3O plus minus Ka اللي هي 10 to the negative 3.2 times C which is 10 to the negative 3 equal to 0. You have a quadratic equation where H3O plus is basically X. So simply على calculator, don't do anything else. Just find H3O plus وفيكم على الكالكوليتر تحطوا 10 to the negative 3.2. remember that. Okay, so this is 5.392 times 10 to the negative 4 molar. Then the pH is equal to negative log of H3O plus اللي هي 5.392 times 10 to the negative 4, which is approximately equal to 3.3. Oh, I think no, it's 3.26. And this is part B of number 18. Good. This is number 18. Completely done. How do you find the pH according to the validity? Okay, pH of a weak acid. Number 19, calculate the pH of ammoniac solution. Ammoniac is basically NH3, and NH3 is a base. Then I know that it exists as NH4 plus, which is the acid. You have it's a weak base, you have its concentration, you have its pKa. So you follow the validity of a weak base. It's very simple. Number 19. Validity of a weak base tells you that the pH is equal to 7 plus half pKa plus half log C. If it's greater or equal, then pKa plus 1. So that's 7 plus half. Ammoniac has a pKa of 9.2. Sometimes they give it as 9.3, so just pay attention. It's 9.2. Plus half log 10 to the negative 4, correct? Yes. Is it greater or equal than 9.2 plus 1? So that's basically 10.2. Calculate it. You get an approximate value of 9.6. Greater or equal than 10.2? No, it's not. This is not valid. This first validity is not correct. Move strictly to the third. هيدي الفirst. Move to the third اللي هي quadratic. Again, because concentration هون it's not enough for the base to behave as a strong base. No, it's not. So, quadratic HO minus plus KB times HO, square. There's a square here, okay? Minus KB times C equals to 0. كلنا بنعرف نجيب KB. He basically 10 to the power, what's the pKa? 9.2 اللي هي pKa minus pKw اللي هي 14. It's the difference between pKa and 14 لأن احنا قررنا أن نشتغل بس between 0 and 14. Okay, so it's pKa, pKw. Okay, you can find where I got this relation. into you know that Ka times Kb is basically Kw. So insert negative log and you can find Kb. So this is equal to 10 to the negative 9.2 minus 10 to the negative, 9.2 minus 14. Okay? 10 to the negative 4.8. And this is your Kb. So now you have Kb and you have C. Simply find the value of HO minus. Using the calculator, HO minus is approximately equal to 3.2 times 10 to the negative 5 molar. Then the pH is equal to 14 plus log HO minus. Don't take only 3.2. Okay, it's never enough. لا ناخد بس 3.2. This is never enough. You need to at least 2 numbers or 3 numbers after the point. Okay, so I think this is 3.27. I don't remember, 75 times 10 to the power negative 5 and this is equal 9.5. Okay, do you see how close it is to 9.6? That's the difference. And yes, you will see that small difference. And you have to know which validity to use. Okay, that was number 19. Let's do number 20, and that's it. A diacid has the following successive acidity constant: pKa1 اللي هي 3. أكيد pKa1 has to be less than pKa2, which is 6. Determine the pH of the diacid solution in each of the following cases. So, I think I will do the first one, and you have the second one as a homework. Okay, let's do the first one. H2A at 10 to the negative 1. It's very simple. نحن قلنا إنه when you have a diacid, you basically have H2A مع H2O. I'm not going to write it completely. HA minus with H3O plus. This is the first acidity. Second is HA minus, again with H2O, to give you A2 minus plus H3O plus. So you actually have two contributing factors to H3O plus. This is the second acidity. To simplify this system, we can neglect the second acidity only if Ka1 is greater or equal to 100 Ka2. خلينا نقول greater بدون equal is greater than Ka2. For Ka1 to be greater than 100 Ka2, it means there should be a difference in pKa that is at least 2. Log 100 is basically 2. It means the pKa1 should be less than pKa2 minus 2. But you can feel difference بيناتهم of 2. And if you look at it, you do have a difference of minus 2. So, to neglect the second acidity, the pKa1 should be at least 4. And your pKa1 is 3. So you can neglect the second acidity. You can definitely neglect the second acidity. يا Ka1 بتكون أكبر من 100 Ka2, or الفرق بالpKa's has to be at least 2. And I do mean that pKa1 has to be less than pKa2 by 2. Okay? It should actually be negative. Because pKa1 has to be, if you take it as pKa2 minus pKa1, the difference has to be at least plus 2. Okay. Because this is verified, then I can, أكيد هاني أنا عم بشتغل only, this is only for part 1. Okay? Then I can neglect the second acidity. And if you notice, even if you change the concentration, you can still neglect the second acidity. It's not a matter of concentration hon. It's a matter on how you calculate the pH. Because I can neglect the second acidity, you have the opportunity to treat H2A as if it's a monoacid. Cancel شيء اسمه second acidity. If it is a monoacid, if it can be treated as a monoacid, it means the pH is equal to half which pKa أي acidity أنتو choose to work with 1 minus half log C. If it's less or equal than pKa1 minus 1. Okay? It's very simple. So, you have to find this value. He basically have 3, which is 1.5, minus half log C, C, which is 0.1. Is it less or equal than 3 minus 1, which is 2? Okay, so you find the value and it's valid. That's good. this is your pH. Now, try to do number 2 as a homework and see the difference between 1 and 2.